So in the last section, we saw how we can store a list of the rewards and also store a list of the number of times a particular action have been taken to estimate the action values. Okay, now we ended at a point where we were beginning to think about how we could keep a balance between exploration and exploitation. And exploration, so I'm going to draw our environment again where we have 3 doors. Okay, so we have 3 doors. Exploration simply means learning about the environment. So you learn about the environment. And exploitation simply means taking the best known action. Okay, so epsilon greedy is a mechanism which helps us to keep a balance between exploration and exploitation. And like I've explained here, exploration simply means you want to learn about the environment. And exploration is very important because that is how you get to know about the reward rate of your each of the doors or each of the actions. And even more importantly, in an environment that has a dynamic distribution of rewards from each of these actions. So what I mean is that the probability of getting a reward from opening each of these doors is not static, but it's something that changes over time. Okay, so in such a scenario, it becomes important for you to leave a room for exploration, and that is what is going to help your agent to adapt to a changing environment. Otherwise, if you just go ahead and do exploitation from start to finish, and remember you have limited trials. In the example I said you had 100 trials. Okay, so if you start by exploiting the best action all the way to the end, the question is, how do you even know the best action to take if you have never explored? Okay, and the other problem with exploring all the time is you will not meet your expected goal. The goal here is to maximize your expected reward at the end of the 100 trials. So if you keep randomly opening each of the doors, it isn't guaranteed that you're going to come up with the biggest amount of money ever that you can make out of this system. Okay, so we need to find a way to balance between exploration and exploitation. So the epsilon greedy is an algorithm that helps us to achieve a balance between exploration and exploitation. And the way it works is that you set a parameter called epsilon to a value, say x. Okay, so what epsilon equals s means is that for x number of times you would want to explore. And what it means is, so for x number of times you want to explore. Okay, and then because probability is always sum up to 1, you are left with 1 minus x number of times for you to exploit. So obviously you can see that epsilon has to be a small number, but not too small that you don't explore at all. It shouldn't also be too large that you waste most of your trials exploring instead of taking the best known action. Okay, so what happens is usually you can start by setting exploration to something as big as 10, which is 0.1. So what it means is 10% of your trials you want to dedicate it to exploring, like taking random actions to observe the action value for each of the actions. And for 1 minus x, which is 0.9 times, you want to take the best known action, because once the action value has been able to indicates to you which action is the best thing for you to take in each step. You want to maximize taking those actions and also allow rooms for exploration. Okay, so what happens is you start by generating a random number. So you set epsilon. So I'm going to say your trials. I'm writing a pseudocode here. So your trials is equal to 100. Okay, so for I in range trials, so from 1 to the number of trials, I've ended up writing almost valid Python code. I want this to be a pseudocode. So from I equals 1 to trials, what you want to do is you want to generate a random number. Okay, so you generate a random number, but at this point you would have set your epsilon. So let's say epsilon is equal to 0.1. This is a big number for most cases, but for the purpose of explanation, I'm going to keep it at 0.1. So what you do is you generate a random number. Okay, so you generate a random number between 0 and 1. Between 0 and 1. And then you check if the random number is less than your epsilon. If it is less than your epsilon, then you want to take a random action. Otherwise, you want to take the best action. So this rough pseudocode here is what helps you to implement the epsilon greedy algorithm. So you reserve a certain number of times in your time steps or your trials for exploration, and the larger chunk of it is going to be reserved for exploitation, where you are actually taking actions based on the calculated action values. And the reason why this is important, once again, is because you want to allow yourself room for exploration, just in case. It could be that you are thinking door 2 is the best door, but in actual sense, door 3 is the best door. If you do not keep exploring, you miss out on getting some of these goodies out of the algorithm. So you set your epsilon to a value between 0 and 1. Usually let it be at the lower end. And like I said, 10% of the time, reserving 10% of the time for exploration out of 100 trials means you are using 10 of your trials for exploring, which is not a bad thing. But for certain types of problems, even 10% of exploration is too big, and you can go as low as 0.01, which is 1% of the time. It depends on the nature, and these things you can learn by iteratively tuning the values, and then you see what works best for the particular problem. So there's no magic when it comes to the value you need to set. The only thing you need to remember is it needs to be a small enough number. But for different problems and different scenarios, different values are going to give you different performance. Okay, so what happens is for each of the trials that you do, you start off by generating a random number between 0 and 1. And if the random number is less than epsilon, because the random number generator should decide that it generates only floating point numbers between 0 and 1. So if you set this to 0.1, what it means is that anything from 0.1 to 0, you want to do exploration. So you take a random action. Otherwise, you take the best action. How do you take a random action? To take a random action, you just generate a random integer between 0 and the length of your action values list. So if you have 3 doors, you generate a random number between 0 and 3, which in Python will give you random numbers, which is who could be 0, 1, or 2. So it gives you 3 values. And then whichever random number you get, you use it as an action. So you say, okay, I'm going to take action 1, which means opening door 1, action 2, which means opening door 2, and action 3, which means opening door 3. And keep in mind that you do 0 indexing. So if you generate between 0 and 3, in Python it will give you, in some programming language you get 0 to 2. But in Python, you can actually get 0, 1, 2, and then 3. So in our example, because we have 3 things in our cell and we have 3 entries in our list, and we are counting from 0, we actually generate a random number between 0 and 2. So you could have 0, 1, or 2, and each of them tells you which action to take. So 0 is for door 1, 1 is for door 2, 2 is for door 3. Okay. Now, otherwise, if it is bigger than epsilon, then it means you want to take the best action. So you just write your code to take the best action. How do you take the best action? To take the best action, you need something called argmax. Okay. So if I have a list, say 5, 9, and 2 as a list, and I call argmax on this. The argmax is a function that basically tells me the index where the biggest number is. So automatically I know that 5 is at index 0, this is at index 1, this is at index 2. So you calculate argmax of your action values, because the action values is what is giving you the estimate of each of the actions. So once you calculate your argmax of the action values, you get the index where the biggest action value is, and that represents the action that you should actually take. So in this particular instance, the argmax is going to return 1, because 9 is bigger than 5 and it's bigger than 2. So the argmax is equal to 1. If instead I had this here and I had, let's say, 7 here, then the argmax is going to be 0, because 9, which is the biggest in this array, is where the biggest number is. So the index is going to be 0. And to implement this in Python, assuming we have calculated our action values, so this is action values, a values is equal to, let's say, 0.9, 0.7, and 0.2. Okay. For me to know which action to take during the exploitation phase, what happens is I'm going to take the max of this array. So if I call max of action vals in Python, is going to return 0.9, because 0.9 is the biggest. Okay, then I can find the index of 0.9 in the action vals array. So the best action then becomes a val. So I'm going to call this max val. Okay, so what happens is best action is equal to a val dot index of, you find the index of your max val, which is also the argmax. So it gives you the position where the biggest number is in your array. And this is a very simple reinforcement learning algorithm that helps you to take decisions under uncertainty. So in the next section, finally, I'm going to bring the robot back, and then we will design the reward system and how it senses the environment and everything, and then we move on to writing the code.